Okay, so the very first thing that I want us to do is kind of discover our exponent rule for negative exponents, just like we did with all the others. All right, if you're talking, you can't pay attention to what we're doing. So the first one is done for you. If you would write out 2 factors of 2 on the top and 5 factors on the bottom, that would leave you with, you'd have to cancel 2 pairs, and you'd be left with 1 over 2 cubed. Our rule, though, we learned earlier on, I'll tell you what page it was on. We learned earlier on, okay, that on something like this, that you can subtract the exponents. So what do you get when you take 2 minus 5? Not positive 3, but negative 3. So what I want to point out to you is when you have a fraction raised to a negative exponent, what that does is it moves it from the numerator to the denominator of the fraction. All right, let's do another one. Would you write out 4 factors of a on top? Would you write out 9 factors of a on the bottom? How many can we cancel?
4.
We're going to cancel 4 pairs. Okay, when we do that, what we have left on top, because a divided by a is not 0, it's 1. We have a 1 left on top. And how many factors of a are still left on the denominator? 5. So 1 over a to the 5th. So if I was subtracting exponents, 4 minus 9, so a to the 4 minus 9 is a to the negative 5th. So this is how it's written as a negative exponent. This is how it's written as a positive exponent. Those are the same. We call those equivalent statements. All right, try the next one. See if you can do the whole row. Okay, after you wrote them out, did you get 1 over x to the 4th?
Yeah.
And then over here, did you get x to the negative 4th? Make sure you have those 2 things. Okay, let's go backwards. Let's rewrite this statement. How many factors of x do I have on the top?
3.
So that would be x cubed, and then we have a y. That's on the numerator. And on the bottom, I count 1, 2, 3, 4, 5, 6, 7. So x to the 7th. Okay, so if I was simplifying that, 3 things, or 3 factors would cancel. What's left on the numerator? Y over x to the 4th. If we use our subtraction rule, we would have y, or x to the negative 4th times y. And so when you have 2 numbers and one of them's a negative exponent, that moves it to the bottom of a fraction. So this x to the negative 4th moved it to the bottom of the fraction. Okay, let's see if we can do this without writing it out. I'm a little nervous about this. If you still feel like you need to write it out, then write it out. Okay, I started it out here. Everything cancels on the top. On the bottom, you're left with a to the what? 4th, and b to the 2nd. With your subtraction rule, 4 minus 8, this is the same as a to the negative 4th, b to the negative 2nd. So what does a negative exponent mean if you had to describe that to somebody? If you see it just like this, what does that mean to do? Like, how would you write it like this? Negative exponents don't mean to make the function negative. It means that you take the reciprocal. And by reciprocal, I mean something becomes a reciprocal when you flip it around. So the bottom of, if it's on the bottom of a fraction, to take the reciprocal, it moves to the top. If it's on the top of the fraction, it moves to the bottom, and vice versa. Are positive expressions with negative exponents negative? No. Negative exponents will never make anything negative. They have to do with the subtraction of exponents. It tells you where to put the exponent, on the top or the bottom of a fraction. Yes. This?
Yeah.
Reciprocal.
Like after the P.
R-O-C-A-L. Sorry, that was a messy. Here, I'll write it either. Reciprocal. Okay, let's do some examples. So from before, so when an exponent is negative, we can think of it as taking the reciprocal. In other words, x to the negative n is 1 over x to the n. A reciprocal means you flip the fraction around. And I'm going to add one more thing, just because sometimes it happens. What if the negative is on the bottom? Then where do you think it moves? How would I make this positive, do you think? Use some common sense. If x to the negative n moves it to the bottom, it's like it was on the top, now it moves on the bottom. What do you think that would be? Do you know how to take reciprocals of things? What's that? You don't know what the word means? So the reciprocal of 2 is 1/2. A reciprocal is a number that you could multiply the number by and you'd get 1. 2 times 1/2 is 1. What's the reciprocal of 1/3? You're going to flip that fraction around. The reciprocal of 1/3 is 3. Okay. So what I'm saying is, if this is a negative exponent, to make it positive, I move it to the bottom of the fraction. If the negative exponent is on the bottom of the fraction, to make it positive, I move it to the top. So it just becomes x to the n. Okay, let's do some. 4 to the negative 2nd is 1 over 4 squared. On this one, I actually could figure it out because I know what 4 squared is. Somebody tell me what 4 squared is? 16. So this I'd write as 1 over 16. All right, h to the negative 7th. 1 over h to the 7th. Nope, nope, it's an h, so we're going to leave it. How would I do n to the negative third? So 1 over n to the third. Okay. This time it's 1 over t to the negative fifth. To make it the exponent positive, I move it to the top. It's just t to the fifth. You could write over 1 if you want, but it's just, that's really what I did, is I flipped it up. All right, ooh, let's be really, really careful. Even my pre-calculus students get this wrong. What's the rule for this? What do I do with those exponents? Subtract them, right? So I'm going to do that rule first, but what I want to point out to you is if I did -5 minus a -7, what does that mean? It means -5 plus 7, doesn't it? And -5 plus 7 is 2. That would just be n to the second. Okay, do you remember your rule when it's multiplication? Do you remember what you do? Add your exponents. This is 5 to the -6 plus 8. -6 plus 8 is 2. This is 5 squared. Last rule. What about when they're power to a power? What do I do with those? Multiply them. And we want to be careful because a negative times a negative is a positive. This would be x to the 32nd power. Okay. Let's take our time here. So here's what's going to happen with your negative exponents. I'm going to write out, basically whatever way you can have to understand it, I'm okay with. But I'm going to write it out, and I'm going to show you how it makes sense to me. 6, I leave. 6 is, there's nothing I can do to simplify this. Then I have times c to the third. How did we just learn to write d to the -2nd? 1 over d to the second. So then what I do is I put it all back together again. So numbers that are out in front go on the top. So I have 6c to the third on the top, and then d to the second on the bottom. Some students don't need to write that in between step. If you don't need to write it in, and you know, oh yeah, I know that d to the -2nd just makes it on the denominator, then you go right to that step. I need to sometimes write it out. Okay, here's what we're going to do. We're going to do our exponent rule first, and then if it's still negative, I'm going to rewrite it. This is x to the 4th times x to the -10th. What do we do with those? What's our rule? Add them. So we have 6x to the, can you tell me what 4 plus -10 is? Is it 6 or -6? -6. Okay. Now I said no negative exponents, so I rewrite x to the -6 as 1 over x to the 6. This is 6 over x to the 6. Okay. 2 to the 0. We talked about this in our opener today. 2 to the 0 is 1. So we're going to leave that alone. What do I do with my exponents here? Multiply them. All right, so I simplify this as x to the negative 12th. Okay, we've been doing this like several times now. How do I rewrite that? 1 over x to the 12th. All right, let's do some with the fraction bar. So what we're going to do first is we're going to do our subtraction of exponents, and then we're going to rewrite it. So what's a to the 12th over a to the 5th? Subtract those exponents. What's 12 minus 5? It's going to be 7. I'm going to write that there, okay? For the b's, be really careful. This is going to be b to the negative 3 minus 5. If you need to use a calculator, use a calculator. 12 minus 5 is 7, so this is a to the 7th. But negative 3 minus 5 is negative 8. What does that make the b then? How would I write that? 1 over b to the 8th. So I have an a to the 7th on the top and a b to the 8th on the bottom, because 1 over b to the 8th is the same as putting it on the bottom of the fraction. Okay. That's crazy. This is a crazy one. A to the negative 2nd and a to the negative 5th. I think we talked about that already. That's going to be a to the negative 2 plus 5, right? Isn't minus a negative make it plus? Okay. The b to the negative 4th is 1 over b to the 4th. If the m to the negative 3rd is on the bottom, it becomes, I move it to the top. So it becomes m to the 3rd over 1. Let's see, I addressed the a's, I addressed the b's. Ooh, let's do the c's. And then that's times, I'm going to scoot it over here, c to the negative 7 plus 3. All right, you guys tell me, a to the negative 2 plus 5, is that positive or negative? Negative 2 plus 5, is it a positive or negative 3? Positive 3. Positive exponents, we have it on the top of the fraction, so it's going to be a to the 3rd. Obviously, this is on the bottom of the fraction, so I put it on the bottom of the fraction. M to the 3rd is on the top of the fraction. What's negative 7 plus 3? Is it a positive or a negative? Negative 4. So where does it go? Top or bottom? Bottom. Okay, last example. Power to a power. When you have a power to a power, you're going to multiply your exponents. But first, let's add the exponents. So what's in the middle is 3, or g, to the 3 plus negative 2, which is 3 to the 1st. Agreed? And then it's raised to the 4th. What do I do with my exponents now? Multiply them. So that's g to the 1 times 4, or g to the 4th.